Welcome back. I'm the IT kid, and this week we're going to be covering operators in Python. And essentially, what operators are, they'll be in between functions that are either comparing at, looking at, and imposing some kind of effect on an equation on either side of the operator. So it'll be some kind of thing in the middle, and it'll be surrounded by two things on the side. And you're going to be either comparing those two things, changing one of them, changing the other, or you might be affecting both. And there are four essential types of operators, and those are arithmetic operators, comparative operators, logical slash bitwise operators, and assignment operators. And each of these will be doing functionally different things. So we'll go through each one of them one at a time, and then we'll go into Spider to look at how each one of them will actually look in code. So for arithmetic operators, these are things that you will know just as math, although in Python, their symbols might be a little different. For addition and subtraction is just about the same. You use the plus and minus sign. For multiplication, however, because there's not really like a multiplication X symbol on the keyboard, although there is an X, what you're going to want to use is the star symbol. So if you use the star symbol in Python, that is emphasizing or representing multiplication, rather. For exponents, it's a star, but two stars. So if you put two stars followed by a number, you'll have the exponent of another number. And if you can see, you can kind of identify, what I was talking about with the operators, how addition is a plus symbol. So if you have two things on both sides of the plus symbol, you'll effectively be operating on them and changing them. That is an operator. And it's the same with the rest of the operator types, but arithmetic is the easiest to understand. So those four, hopefully those symbols are clear, but you star for multiplication, double star for exponents. And there's still a little bit more for arithmetic. So in Python, there's essentially three different types of division. The first is called floating point division, and that's represented by a side slash. So this is floating point division. Wow, can't spell. Floating point division. And what this essentially means is that it just divides the two numbers and it'll give you the decimal place no matter what. So if it's 5 divided by 3, you'll get 1 point blah, blah, blah. If it's 5 divided by 5, you'll get 1, but you'll get 1.0. So floating point division will always give you that floating point. That's why it's called floating point division. The second is represented by double side slash, and this is floor division. Floor division basically means that it will always round down. And so if you have a decimal point, it completely truncates it, it removes it, and you just have the number. So if you get the answer of like 3.33, you essentially just get 3 if you use floating point division. And I don't know, with your discretion, you want to use different types of division depending on what you're trying to do. If you have a negative integer for floating point division, though, understand that the floor is actually the next negative number. So if you have negative 3.33, it's not going to round to 3 or it's not going to round to negative 3 because that'll be rounding up. It's still going to round down to the floor. So you'll get negative 4. And the last thing is the percentage symbol in Python, which is known as the modulus. And what you're doing here is modular division. And this is essentially just finding the remainder. If you divide 5 by 3, you'll just get 2. So you're getting the remainder of the equation. You put that percentage symbol in there, you're finding the remainder. And now on to comparative operators. Comparative operators are what you known as greater than, less than, things like that. They compare one side of the equation to another side of the equation. In Python, these symbols are essentially the same. This facing the number that the symbol is facing is greater than. The number that it's facing away from, it is less than. Or maybe that's kind of confusing, but I feel like it should be easy to understand. In whichever way that the symbol is facing, that number is the greater number. And whichever number is at the tail end of the symbol, that number is less than. And in Python, if you want to represent greater than or equal to or less than or equal to, you're just going to add the equal sign. And this will change it from just greater than and less than to greater than or equal to or less than or equal to. And you also have regular equal to. Whenever you're coding normally, you'll see that when you're assigning something to a variable, you put one equal sign. And that's how you set something equal to something normally. But if you're using an if statement, a while statement, a for loop, some kind of statement like that, if you're trying to identify if two things are equal, you have to use double equal to. It's very different. The regular equal sign is saying this number now, or this variable is now equal to the thing on the right. Double equals is checking to see if both of them are the same thing. This is the true equal to. And then you have the exclamation mark equal to. And what this means is not equal to. So this will be useful if you're trying to find out that if something is not equal to this, then you might want to do something else. Next, we'll have our logical and bitwise operators. And I know I say two different things, but what it is essentially kind of the same. And these are, again, logical statements. So when you're thinking about two parts of an equation, you might want to look at how they relate to outside of the comparisons. So in our logical operators, we have things like and, which can simply be represented in Python just as and, all lowercase, and or. So what you're saying in this instance is that, or what you might be saying is, if you're using an if loop, a while loop, or a for loop, is while this number and this number are true, you'll carry out the contents of the loop, of the if statement, of the while statement. And so you do the same with or. These are logical operators. The key thing to note, though, is that there's two types of ors. There is inclusive or and exclusive or. Inclusive or says if this is true or this is true, or if both are true, you can run the program. But exclusive or, also sometimes represented as XOR, although not in Python. You can't write XOR in Python. But exclusive or will say you one or the other. Like, both cannot be true. It has to be either one or the other, and then the program will run. In Python, to represent the actual XOR, you're going to want to use the upside down hat. And I know sometimes when you're just writing, generally typing on the laptop, this is commonly the exponent symbol. But when you're using this in a comparative statement where you're using operators, you're saying this exclusive or this other thing, you're going to want to use this symbol. And this is essentially what is known as a bitwise operator. So you have to be careful whenever you're using the bitwise versions of these statements, because or also has a bitwise version. It's just the regular slash, down slash. And for and, it's the little and symbol. I'm not sure if I'll be able to, but yeah, it's basically that. So if you put in the and symbol, you'll get and. And if you put in a down slash, that is the symbol for or. And there is one last logical operator called not. And this is essentially this can be represented as squiggly lines. I'm not particularly sure if not can just be run as a regular logical operator, but I'd say run as a bitwise. And again, you have to discern. The bitwise version of these operators will take priority. So you have an equation on one side of the logical operator and an equation on the other side. Instead of looking at both equations first and then comparing them, it's going to look at the two sides of the equation that is near the bitwise. So if you have 2 plus 3 equals 5, or 3 plus 2 equals 7, for instance, instead of looking at both of those equations, you're going to have the 5 at the end of the first equation and the 2 at the end of the beginning of the second equation, and it's going to use the or comparison on both of those first, and then it's going to run the outside. So that takes priority. So make sure you're putting parentheses around it if you want to, run two equations on either side of the bitwise. Last but not least is not comparative, but assignment operators. And assignment are those little shortcuts, one of which I pointed out yesterday. And an assignment might be plus equal to. And what this essentially does is it adds whatever numbers on the right side to the variable on the left side. And you can do this with any other arithmetic operator. You can do this with minus equal to. You can do this with divide equal to. You can do this with multiply equal to, etc., so on and so forth. And basically, you're performing the arithmetic using the integer, the double, the value on the right side, and you're going to do that on the variable on the left side. It's very quick, very easy to understand. Hopefully, it's not too complex, but now we're going to look at it in Python, and hopefully that'll make things even clearer. Okay, so what's happening on the screen, you might see a lot of moving parts, but I have most stuff grayed out with comment blocks, and we'll essentially look at it one by one. So at the top, we have our import statement, which you don't really have to worry about. It doesn't have anything to do with what we're covering this week. It'll just help us go through our examples. But as you can see, here are the references for the operators. And as we go through it, I'll keep these references in the top right corner of the video so you can look at them and try to guess to what it might do. So over here, you see the arithmetic operators, the symbol that you use in Python. You can see the comparative operators, you'll see the logical operators, and then you have your assignment operators. So let's look at our actual code itself. So you see, we have variable n, which I set equal to some random number between 1 and 9. And this code, you don't particularly have to worry about it. I'm not even going to really touch it in this video. All you have to know is n is a random number between 1 and 9. And the same thing happens to m. X is equal to n plus m. That is our first arithmetic operation. So as you can see, and again, get in your head that the regular equal sign is not necessarily an operator. You're saying x is this value on the right, not x is functionally equal to. You're not comparing it in that way. You're basically just saying x has to be what is on the right. So x is equal to n plus m. Now, if you run the code, it's going to print the value of n, it's going to print the value of m, and then right here, it'll print n plus m is equal to x, which is both of them combined. As you can see, it's here, 3 and 5. 3 plus 5 is equal to 8. And if you want, copy this code down. You can play around with other arithmetic operators, although I don't think that it would necessarily be a good use of your time for me to do so with every single arithmetic operator. But as you can see, if I just change what it says, then 2 minus 8 equals negative 6. You can multiply it. 9 times 6 equals 54, so on and so forth. Use those arithmetic operators. Try to compare them and see what outputs you get when you run it in a console. Although you don't have to use code as complex as mine, you can still copy it because I find it kind of fun. But make sure when you're using this random variable, when you're making n and m random, make sure you do this up here. Make sure you import random, which will get the database, the library for the random method or the class, which we'll cover probably farther down the road, and it will allow you to use this. So you can't use this unless you import random. Now with the arithmetic out of the way, let's go to our comparative operators. So here you have greater than, equal to, less than. And so after we assign a random variable of n and m, you're gonna see that we're gonna be comparing them. So if n is greater than m, it's gonna print n is greater than m. And here, since I kept this uncommented, it'll print both values of n and m. N will be the one on the left, and will be the one on the right, as here as usual. So let's run it. We get n is equal to 5 and 7 is equal to m. 5 is less than 7. So it ran the last elif statement. Else if n is less than m, print n is less than m. And these are, again, comparative operators. It's comparing one side of the equation to another. It's comparing n to m, and it's saying if n is this thing, so if n is less than m, or if n is equal to m, or if n is not equal to m, or if n is greater than or equal to, run whatever code is under that block. So it's like what I covered last week, if and while this, or if this part of the equation is equal to true, like a Boolean, you'll say run the indented code that's inside of that. So after we get a random number, it'll go through these options. It'll say, is n greater than m right here? No, so skip that. Is it equal to m? No, so skip that as well. Is it less than m? Yes. So it'll go to the code that's inside of that, and it'll say 4 is less than 6. This was the crux of what we covered in if while statements. If, elif, else. So let's comment that again. Now let's go to our while statements. Before we look at the bitwise versions of these, let's look at the regular logical versions of these. So if we read the code here, what we're saying is while n is less than or equal to 20 and m is not 25, n is add a random number between 1 and 5 to n, and add a random number between 1 and 5 to m. And so what you're going to do is you're going to print the new value of n is equal to this, and the new value of m is equal to this. And it'll keep going until one of these variables is no longer true and disrupts the while loop. Because for this while loop, both of them have to be true. It is an and statement. It is a logical and. This and this both have to be true for it to run the code. And if you run it, you'll see at first n is equal to 5. Both of them are equal to 5 actually. And it seems that they both randomly also add 2. Then n, it randomly adds 3, randomly adds 2, randomly adds 1, randomly adds 3, etc., so on and so forth. And once n is no longer less than or equal to 20, it breaks it because both sides of the equation are no longer true, so the while loop cannot run. Now, if we go to remove these parentheses, you'll see that it functions essentially the same, although I would advise that you always use parentheses when you're grouping the equations that you want to complete before the operation. Like, just make that a habit of putting them in parentheses. But if you go here, you'll see that it runs just as good. It'll keep adding it until one of the equations is no longer fulfilled. But if you're using a bitwise version, it might be a little different because, like I said, this takes priority. So what it's essentially doing is this and this So while 20 and m are either great greater than or equal to n or not equal to 25, keep running this code. So it's grouping this up, making it a middle statement. And like I said, while 20 and m instead of while n is less than 20 and m is not equal to 25, it's 20 and m while they're greater than or equal to n and not equal to 25, you're going to run the code. As you can see here, it only prints the 7.3 from above because although it would be hard for me to like fully analyze and explain what's really going on in the middle, you should just know that you shouldn't do that if you're using the bitwise version. Whenever you're using the bitwise, you must 100% of the time make sure that you have the parentheses on because the bitwise takes priority. It's like PEMDAS, except they put the bitwise operator at the start of PEMDAS. So it's like B PEMDAS. So you're going to run it and it'll run properly as long as you have their parentheses where they belong. And this is the same with or, but for this equation, it's while n is less than or equal to 20 or m is less than 50, run the code. And while either one of these equations are true, it'll run it. Or even if both equations are true, it'll run it. But if you do XOR, then only one part of the equation can be true. Both cannot be true. And in this situation, both are true. So it just does not run it. So XOR is exclusive OR. You cannot have both sides be true. It has to be one or the other. There are use cases for this. It determines for you where you want to apply and use this, but this is the XOR operator. Now let's look at maybe nesting these operations within each other. So or not even nesting, because I might cover nested loops and nested if statements more in a later video, but let's try to briefly look at assignment operators. As you can see, they're highlighted right here. Although they don't really get their own exercise or their own practice, you can see the use case very easily. If we change this to be minus, it will be, or in fact, let's copy this and then let's turn this whole thing into a comment block. And so let's remove that statement. Let's do this. N is minus equals to a random integer between 1 and 5. So as we said, you're essentially taking whatever's on the right side of that operation and you're just applying the whole equation. So what this is equal to is you're saying n is equal to random dot rand int between 1 and 5. And let's get the n for there. Let's go. N is equal to n minus random dot rand int of a number between 1 and 5. But you're shorthanding it. So you're just saying minus equal to. It makes it much easier. It makes it much better to look at, much easier to read. And that is essentially the function of assignment operators. So that's functionally and essentially it for operators. Again, here is the list of references. These are the ones and their symbols in Python. So thank you for watching the video. I hope you learned a lot. As you can tell, it's a very much more planned out video. I'm going to be doing this from now on instead of just freeballing and free throwing out lesson ideas for other videos, so I can kind of build off of past ideas, because as you can see, the order was a little bit backwards with if and while, because you were using if and while statements without fully knowing all the operators. But now that you know the operators, go back to that if and while video and try to see what kind of code you can make. See what kind of if statements you can make, what kind of while statements you can make using these arithmetic, comparative, logical, and assignment operators. Thank you. Have a nice day. If you like the video, like and subscribe. I'll catch you all. Bye.
없을 리본 내 귀스트로